here. This is eagerly anticipated dialogue discussion. I guarantee what you see here kind of parallels, what the task force is trying to do. What AAC is trying to do is to come up with more risk-informed, risk-based standards and tools. So let's get right into it and see what's coming and what the potential and how the task force can rally behind it. Thanks, David.
Yeah, go ahead, David.
All right. Well, thanks for the invitation. I'm a last minute stand-in, so please forgive me if this is a little rusty, but looking forward to sharing with you all. The future of flood risk data is simply a change initiative inside of FEMA for Risk Map, which is the program that we use to execute the statutory authorities for flood mapping for FEMA and the NFIP. And being a change initiative, we all know change is hard, particularly when you look at the types of products that FEMA has produced over the last several years. So I was trying to think of a nation that would represent how mine fits inside of the FEMA DHS family, building on the Switzerland one that was shared, and found that there are none that are safe sharing. Switzerland's the only one that you can use in that type of analogy. So we are working hard across FEMA to and particularly the programs in the National Flood Insurance Program to drive a shift towards a better understanding of flood hazard and flood risk to support floodplain management, land use management, the execution of our grants programs, and ultimately improving our premiums that we establish for flood insurance for the National Flood Insurance Program. So that's what we do on a regular basis. So I'm sure many of y'all are familiar with the flagship product of our program. It's the Flood Insurance Rate Map, which is used primarily for determining where mandatory flood insurance purchase is applicable for federally backed mortgages and defining the absolute minimum that you can do from a floodplain management standpoint to stay in compliance and have flood insurance made available. Having the same program and the same standard in place for 50 years has major unintended consequences. Unintended consequences. One of those is not being able to keep up with the advances in science and technology, the inability to adapt and account for changing conditions, be they land use in a timely manner, or changes as a result of impacts of the climate. Sea level rise is an example here. Furthermore, at the time FEMA set this program in place, determination was made that we could do riverine flooding and we could do coastal, but it ignores pluvial and the impacts of heavy precipitation. So not only is the process to change these regulatory maps inefficient and lagging behind changes in the real world, we've also created a de facto design standard across the nation, which has been the 100-year, which again defined a minimum threshold for land use management, but also, as you can see in the major media stories you see after every event, results in a lack of understanding in terms of what these maps were intended to do. Right, if people are shocked in the media every time the flood doesn't stay in the lines we put on the map when the flooding event hits. And so we are working very deliberately to change our approach to deliver better data in support of the many use cases for flood hazard and flood risk information, given the authorities that we have. Two key milestones for this significant shift. There have been reports every decade since the NFIP was established in the 70s, saying FEMA needs to shift to a more comprehensive approach. FEMA needs to shift towards a probabilistic approach as opposed to deterministic, to support this shift from FEMA from a hazard-based approach to land use management and the NFIP to a risk-based approach or a risk-informed approach. And so Biggert-Waters 12, which was passed in 2012, established the National Flood Mapping Program with additional authorities for FEMA, including future conditions, residual risk, and a number of other things that weren't explicitly stated in the original National Flood Insurance Act. And that was followed up shortly thereafter with a consensus study from the national academies laying out a need for FEMA to shift to a flood risk management approach, and laying out in detail um, the recommendations from the national academies that FEMA leverage a probabilistic approach to do that. So the FFRD is our effort over the last 6 or so years to build a foundation and a methodology upon which we could scale to national coverage of physical models that could support probabilistic assessments of flood hazard and flood risk for a full range of flood frequencies, for all flood hazard types, for all areas of the nation, which is a very ambitious task. But simply put, the way that we organize these objectives are to shift from our binary deterministic approach to a probabilistic approach that gives you a graduated understanding of hazard and risk, modernizing our data management and delivery in such a way that we're making the data readily available and not trying to push everything through a map, which automatically limits the value of the data that you produce, such that that data can empower innovation across the private sector, across the federal family, across state, local, tribal, and territorial partners, ultimately to drive more risk-informed actions as opposed to these hazard-based approaches that we're accustomed to. So when you look back, the way we traditionally did things, we traditionally worked from the inside out when we would do riverine studies in particular. So we wouldn't look at the whole watershed. We'd start at a stream center line. We'd cut cross sections. We'd use point-based precipitation to come up with how much water is going to make it to those streams. And we would map out till we got to the 100-year flood frequency, the 1% annual chance, and in some instances, the 0.2% annual chance, the 500-year. So we were really optimizing all of our physical modeling around creating this one blue dot, right? The 1% flood elevation and the 1% annual exceedance probability. In a few instances, we would add additional flood frequencies up to the 500-year and as low as the 10% annual chance. As we look to the future, what we're working to do is establish consistent approaches and standard operating procedures for building two-dimensional models that represent every area of a watershed to enable us to capture the impacts of rainfall, both what we have observed in the past and how that shapes our understanding of flood hazard and flood risk today, and to also build this in such a way that we are able to isolate these variables such that when we rerun these models, we can run them with different land use, different land cover, and different causal mechanisms of precipitation based on, we're not climate experts, but based on what the climate experts say are more plausible conditions in the future. Ultimately, what that enables us to do is for existing conditions, better quantify the full suite of annual exceedance probabilities for more parameters than just elevations, right? So you could have elevations, you can have depths, you can have velocities in coastal areas, you can have surge elevations, you can have wave heights and those types of things. And I'll show you some examples later. But we want to build out assessments across the full frequency space with quantified uncertainty. And that is our primary objective. One thing I'll just add right now that we're doing, we currently have an interagency agreement in place with USGS and with the Corps of Engineers to work on recommendations for better attribution for stream flow data such that we can better isolate the causal mechanisms of those observed stream flows, such that we're able to better understand the causal mechanisms, whether it was rain on snow, those types of things for all the observed stream flow. So when we look at doing these types of statistics, we have that information. Another need that's there for us that we're interested in communicate with our partners at NOAA and the NOAA Atlas 15 team is ultimately better mixed population precip data also, so we can isolate the causal mechanisms for those different events that caused observed precip at locations. So what does that help us to do in practice? Again, I highlight this orange dot, which was blue on the last slide, which was where we used to optimize our modeling around, resulted in a static deterministic floodplain. You're either in or out. We draw a crude boundary when it came to structures that are impacted, and in general that relate to high costs for flood insurance or high average annualized losses for areas that were in the floodplain, and generally lower cost and often subsidized premiums outside of those areas. We've taken a big step forward with updating our premium approach, using a blend of models to come up with actuarially based premiums for the National Flood Insurance Program. But that doesn't get into the need to understand the physical risk in a way that's sufficient for land use decisions and local floodplain management, and that's the gap that FFRD is filling. So when you build out your capability to quantify uncertainty and understand flood hazard types and frequencies across the full range of events, you can start to enable folks to visualize flood hazard and flood risk differently, something that's more realistic with what folks observe on a regular basis. That enables you to better get to estimated annual damages when you combine that with improved damage functions for all locations in a community or all structures. And estimated annual damages is an important missing link, particularly on the FEMA side, before you get to average annualized losses, because to truly be able to understand the impact of flooding in the way that FEMA needs to be able to support communities and survivors, we need to understand what damages are going to be incurred at locations and what structures and what impact that's going to have on people as a necessary step before we convert that into average annualized losses that inform premiums and our ability to run an actuarial national flood insurance program. So just another illustration of that. The structural data, as we work, we're trying to remain agnostic in terms of which structural data set that we are going to use to attribute these graduated hazard outputs that we get from the execution of FFRD. Currently, we're working with the National Structures Inventory just because we're partnering with the Corps on some of these methodologies, but ultimately good structural data combined with the type of graduated hazard information that we're producing and improved damage functions, which we're actively working on. We have a collaboration in place with the U.S. Army Corps of Engineers to improve damage functions, to move beyond the limited utility of depth damage functions and get something published here before long. We have a workshop coming up later this month with some key folks in academia to take a look at some of the work that we've done and provide us some input on that, ultimately to better quantify authoritative data sets released that give you a better understanding of the impacts of flooding over longer time horizons, and then the losses associated with those to inform our day-to-day activities, including rate setting. By isolating those causal mechanisms and designing the framework the way that we're doing, the National Climate Task Force took a look at FFRD when preparing the FFRMS State of the Science report for climate-informed science approach, and looked at this as a promising initiative to get us where we need to be. But I won't deny the fact that it's pretty ambitious, because when you look at where FEMA is today and the gaps in models and how much work is necessary to build out this modeling capability nationally, we're looking at a decade in our latest risk map multi-year plan to be able to finalize methodologies, standard operating procedures for developing 2D models at a national scale, and to produce those. So long way to go. But in the meantime, we have made some great progress in the coastal space. So taking the AdCirc models that we partnered with others to produce as a part of our risk map program to develop the current coastal maps that FEMA has produced. The work that the Corps has done subsequently on the North and South Atlantic coastal studies. We reprocessed some of the work that the Corps done in the North and South Atlantic coastal studies to generate results for the Atlantic, Gulf, Northeast, and Puerto Rico and the U.S. Virgin Islands. And so to give an idea of what it is we intend to deliver, we built a prototype viewer. We don't intend to make this publicly. We just use it to kind of bring to life some of the rasterized outputs of these annual exceedance probabilities that we have for surge elevations and for wave heights to demonstrate what's possible. We have 3 pilots ongoing right now for full Huck 4 watersheds to implement our inland approaches for pluvial and fluvial. But those annual exceedance probabilities aren't ready yet for us to incorporate this. So in this prototype viewer, we'll have some inland results soon. But wherever you see us previewing surge and wave heights in this tool, you can imagine for inland areas, we'll be focusing on depths, elevations, velocities, things that ultimately drive damages for structures. So just a quick walkthrough and then we'll open it up for questions. The first place we generated some of these results was in Slidell, Louisiana, leveraging these outputs. When you go in here, there's some overviews in terms of you can get annual exceedance probabilities for storm surge, wave heights, and integrated coastal hazard. You can get those composited across annual exceedance probabilities. And you can compare different locations and you can get flood hazard curves that represent those different features across the full frequency space. I'll show you a couple examples briefly, and then we will jump into the future conditions one, which we did where we reran the full dynamic modeling suite under 2 sea level rise conditions to create dynamically modeled sea level rise outputs. So I'll close this and jump in. So here you'll see we use the rasters from the outputs of that study. Here in Slidell, I'm going to turn off the structures. And you can see storm surge depths. You can toggle across. We have information from, I believe, the 10-year out to the 2000 to the 10,000 year for this geography, but in this viewer, we just show the 10% annual chance through to the 2000 or the 1000 year. And so you can kind of get an idea of storm surge depths across that full frequency space. You can also look at wave heights similarly, wave heights associated with the 1000 year scaling back through several flood frequencies of emphasis. Of course, we have results in between all of these. We just rasterize these to make it easier for folks to view in a prototype viewer. You can also see annual exceedance probability. This gets to that graduated hazard and component. Because we're still working on improvements to damage functions to get to our next desired output, which would be estimated annual damages for structures and average annualized loss, all you're seeing here is annual exceedance probability. So this is very much hazard focused. I'll just zoom in here real quickly and just show you the ability to, in terms of for future land use considerations, you can choose 2 locations within this area, and you can get their annual exceedance probability of flooding. You can get a bit more detail, but any given location here, you can see with the uncertainty bands applied, the likelihood of a certain flood depth across the full frequency space. So you're able to say, if you want to be 100% certain you're building higher than our best assessment of the current 100-year floodplain, you wouldn't want to build to the traditional BFE, which might be 4 feet. You'd at least want to build 7 feet to be fully confident that you're out of that 1% annual chance, and that might correspond to the 500-year at that location. Similarly with wave heights in terms of construction type, here you would clearly want to account for waves in your design based on estimated, based on this assessment that the impact of waves are likely even in frequent events. You can move over to the next location and see that it's a much less frequent threshold for flooding to occur at that location. Waves are much less of a factor. It looks like we have something going wrong there on the wave heights anyway. There's no values on the y-axis, but provides an opportunity to compare 2 different locations for proposed development and have some sort of idea of if you put something there, how hazardous is the area, how high would you need to build. But traditionally, you probably see many of these locations both just in the same special flood hazard area, the 100-year floodplain on a traditional product. So being able to deliver this, take this to communities, and then have conversations about what regulatory mapping tools do they need to manage floodplains in their community is a much more powerful way for FEMA to approach this than we traditionally do. In talking to John, we believe for consensus codes and standards, these types of outputs can be very valuable for having input across the various hazard frequencies that are important for different infrastructure types and those types of things. I think one more thing that I wanted to quickly show here, if I can zoom out. I hope I'm not making y'all sick. This thing is I usually have a pre-recorded one that I use, but I wasn't able to get a good one ready for y'all in short turnaround time today. Oh, the compare feature, yeah. So I already showed that. So zooming back out, we've also, I mentioned, ran that full modeling suite again with sea level rise conditions, starting conditions. And so we varied those geographically based on where we were. In this location that I'm going to show you near Galveston, based on the 2022 sea level rise report, we chose two starting elevations and then ran the modeling suite and created some outputs that should be valuable. Now, it's always good to have a backup plan. And since that's not working, I can just go to a recorded demo that we have. I was hoping I'd get the live one. But here in Galveston, we this is just a preview of all the different things you can do in the tool. But we have those same features: storm surge elevations, wave heights, annual exceedance, probabilities of flooding. All those are available. You can query across them just like I did in Slidell. But the difference here is if you look just below where the cursor is, you can choose the two different sea level change conditions. The 0.75 meters, and I think the other one was 1.5 meters. We'll see that here in just a second. And once you get that, then you can, we did this slider bar thing where you can just see what for the same frequency today versus under a sea level change condition of 0.75 meters, you can see which areas are going to be inundated. It looks like we did that both for wave heights and for surge elevations. Here you can see this across the graduated frequency space. Yeah, 1.5 meters. Great, I got that right. And so it's just powerful to be able to visualize it this way. Again, this tool's not ready for prime time. It's just to be able to enable people to interact with our initial results. There'd be a lot of additional interagency collaboration work before we would release this, but we wanted to give you all a preview of what it is we're working towards. I think the last thing that I would share is we do have the NSI structural data in here, so you can actually turn those structures on and select them, and you can have the flood hazard curves that I showed you before give you answers as compared to the first floor elevation and construction type of structures. So again, the NSI isn't as accurate and authoritative as we'd like, but it enables you to work with communities on a plan to say, all right, well, if you have this many structures of this construction type currently below the 100-year and under 0.75 meter sea level rise, which based on your nearest NOAA tide gauge, you might be able to say, well, what, in what time horizon, in what decade would you expect that to become part of the 1% annual chance flood or something even more frequently? You could start to work out plans to say, how do we want to rebuild? How do we want to zone? How do we want to plan to make sure that we are not only recovering from the next event that happens, but we're preparing ourselves to be better prepared for the flooding that's going to happen in future events. So this is what we're up to. Again, this is stitched into our multi-year plan, these capabilities and this plan to really change the way FEMA develops flood models to support the National Flood Insurance Program and to support those regulatory outputs that we still need to identify that 1% annual chance, but to make certain that we are bracketing it in this full understanding, this full articulation and communication of the overall flood hazard and flood risk at a location and at a structure to support the programs that are involved with mitigation planning, land use management, and to help them all shift from this hazard-based approach to a risk-informed approach that takes into account the full range of possibilities. This thing is still going on. Again, this is just showing how you can start to look across decades based on the sea level change conditions that we modeled and your nearest NOAA tidal gauge to have an understanding of when those thresholds might be most realistic. Again, since we couldn't model everything, this was a way that we tried to set it up so you could interpolate between some modeled outputs to get some answers at any given location across time scales. So I'll pause there and open it up for any questions or observations. Thanks for giving me the time to share and give that overview.
All right, that sounds great, David. Thank you so much. Do you have a hard stop?
I do not.
Okay, all right. Questions for David?
David, I'll just kind of lead
Go
off
ahead, John.
here. Oh, okay. Yeah, I'll just kind of lead off here, just to share with this group, you know, as this multi-year initiative is underway, that there are some deliverables in the coastal space that is in the planning, or we can look forward to next year. Do you want to say a word about that?
Yes. So the outputs that we use to create those rasters and that prototype in partnership with ERDIC at the core, we intend to make those publicly available by spring of next year, such that these types of things could be generated and produced. There's some steps between here and there, but our intent is to share those raw data sets, the outputs of these models, and have those out there before we get through spring of 2025. Thanks, John.
Yeah.
Excellent. Bilal?
Thank you very much. That's quite informative and timely. I have a couple of questions. When do you think it will be available in the public domain for users and so on? And the second question, I'm a big fan of risk-based and probabilistic modeling, and that's what I devoted all my career to this. But I'm trying to think in terms of the user. Instead of giving them, a binary, you're in, you're out, which is not realistic. I do recognize that. If we bring them, this vague lines, gradual and so on, it will make, and a lot of information. How would it impact their ability to make a decision?
Yes. And so it's a question we ask ourselves routinely. And what we've done is we just completed a customer experience initiative where we engaged a wide range of state and local stakeholders and advanced communities with advanced GIS and flood modeling capabilities who already have some of this data, this type of data, and traditionally communities that traditionally have missed out on even the basic FEMA maps that we've produced, and tried to understand where people are getting the types of information that's driving the flood risk management decisions. What are their sources? What format? What makes a difference in terms of that? And so we've gotten some of those results in this year. We also did an activity with the Center for Open Data Enterprise, and we just got some findings on that earlier this year. Again, that one was very much targeted on underserved communities to make sure that we are getting more input on the types of products and tools that are going to make a difference. But I think, Bilal, the main answer to your question is that the type of product or tool that will be derived from this needs to be variable based on what stakeholders we're engaging and what outcomes they're trying to achieve. And so what my team is doing on the technical side and the engineering side is trying to come up with the data to enable us to go into a watershed, go into a community the way that FEMA does today before we issue regulatory maps, talk to communities about what's next for them. Are they updating a mitigation plan? Are they recovering and rebuilding? Where are they in that cycle? And what product or tool derived from this information is going to be most effective in helping them become more resilient to the next storm, and more resilient in the long term to a better understanding of what's possible today and even some plausible scenarios in terms of what's possible in the future. And so that is a long non-answer, Bilal, I'm afraid, but we have not figured out. The only thing we know is that there's no silver bullet, right? There's no one-for-one replacement to the flood insurance rate map that's going to address all the demands that are there for the types of products and tools to drive informed decision making at scale, community by community, to make the nation more resilient. I hope that's a fair answer.
Thanks,
That
David.
is, thank you.
I've got Terry, then Joe, and then John.
Okay. David, that was a great presentation. Thank you very much. It's very exciting, this direction you're taking. And I'm thinking about it from the practicing engineer perspective based on Bilal's question. It was a great question. Because we have a lot of things that are probabilistically based, but at the end of the day, we have to go somewhere in that curve and pick a design value. And so that might be something to also consider, maybe working with some of the SDOs or whoever it might be to look at that perspective as well.
Agree. Thank you.
All right, Joe.
Hi. I guess I would approach this maybe from the climate data provision side. I'm curious, particularly on the inland flooding. What sort of data is being used? What's desired? Are there any roadblocks in getting what you need to do the kind of modeling you want to do on these sort of drainage catchment scales?
So one of the things that I hit on a couple of them, right? Which is just a better knowledge base to work from, right? So agreeing on what attribution is appropriate for all observed stream flow, going back as far as we can, and then going forward is really important to understand, to be able to have mixed population statistics for observed stream flow. That's really important for calibrating the models that we produce. And then that mixed population for precip type is really important for being able to understand what atmospheric events are causing that precipitation, which varies season to season. You all know this better than I do. But if we're able to better isolate the events that we're using they're being resulting from convective storms, the increased moisture in convective storms in the future, atmospheric rivers, how much more or less prevalent they're going to be in certain geographies, then we're able to come up with better watershed by watershed. We're able to come up with better location-specific estimates of what plausible future flooding is going to look like in the future. And then we also need better land use data sets. What's the land cover going to be in the decade based on the impacts of climate? And then the other thing I would just say quickly is that we're using, in areas where we don't have much gauge data, we're using stochastic storm transposition to fill out the knowledge space. So we're using AORC data sets to come up with transposition regions where something that happened in that transposition region could plausibly happen somewhere else. And we're moving those storms around to create a more representative base so we can get out to those extreme flood frequencies. Sorry, Joe, go ahead.
Well, actually, I did want to sort of follow up on that. I'm a little bit surprised that you're going all the way down to the level of mechanisms of storms, and you're not just downloading some database of 100-year, whatever, 1% precipitation events. So it sounds like you're, trying to travel a lot of the same paths that are being done for like the PMP and other things. But I mean, typically when I've but little research I've done, people who do this kind of high resolution surface hydraulics and hydrology modeling typically use a much simpler version. So it's interesting that you're going to this really complex. Is this documented somewhere? The sort of the approach that you want to take, just so that I can keep tabs on what's being used.
Yes. So right now for the inland, we're finishing our first pilot Huck 4. And so we have a draft set of standard operating procedures for that. It's rough. We're working to get that rewritten now to apply. So our first one was the canal watershed in West Virginia. It's a bit simpler. Only had one major rain on snow event to contend with in terms of a major flood that we had to contend with. We're now moving to the Duwamish, which is the Green River in the Northwest, where we have more atmospheric rivers. And then we're moving to the Trinity in Texas, which is just very which is really going to stress test the thing. But these standard operating procedures, I can share the draft with you now, and we'd love some feedback. And we're trying to get it all documented so this can be repeatable and also allow for geographic specific adjustments, as experts pick this up and try to do this. But we're trying to create a recreatable, reusable kind of set of standard operating procedures for folks to do this, because ultimately we need it to feed.
Yeah, I'm not sure I would do anything with it right now, but it would be nice to have it just for reference to what
Sure.
you're doing.
Yeah.
Please do. Thanks.
Happy to. Thank you.
And I'll quickly go just in the application space for practitioners. I see this directly relevant, and ASCE has kind of already moved ahead and said we're not finished up this year. So I'm very excited about the potential through FFRD and somehow linking up with the ASC hazards tool that the practitioners, designers are going to do what's expected from the standard and be able to access point data around across the floodplain for all of these MRI events, and that's associated with water elevations, water depths, and velocities, and then coastal, still water and wave heights and all of that. Right now, we tell the practitioner to do that, but there's scaling factors and building off the 100-year, right, which is its level of certainty and conservativeness. So I'm excited about again, coming alongside the risk-based, risk-informed, more accurate approach at a site and structure-specific level. Dave, would you be able to come back when the riverine scenario through the viewer is I think maybe the group would be interested to see how that's shaping as well.
Yes. And I'll bring smarter people. I'll bring a hydrologist with me next time too, so we'll do better. But yes. One thing that I wanted to briefly add is that we were paying very close attention to the PMP study, and we briefed that panel on this work as they were putting that together. So we were excited to see their report come out. Obviously, with this approach being predicated on a National Academy's report to FEMA on our need to change, we're paying close attention to the recommendations that they're providing across the flood space. I'm sorry, Marie, go ahead.
Yeah, go ahead, Mari.
Yeah, no problem. And don't do yourself down. So I'm just curious, you mentioned you're working with ERDC. Are you collaborating at all with USGS as well? Because they commissioned NCAR to be running the CONUS 404 atmospheric model, which is then run through the National Water Model. I believe all of the hindcast data for the National Water Model is now available and published, and they're moving on to future projections. So it would be lovely if all of that work is coordinating across agencies.
Yes. So I mentioned the one interagency agreement we have in place with the USGS. We also work with them on the National Hydrography data set and 3D FIC, I guess, the elevation data. Those are all very much engaged. But we also meet monthly with the NOAA Atlas 15, the National Water Model team. So we're staying in close tabs. I think the biggest thing to recognize is the difference in requirements that we have for our approaches. And right, so when I talked to Fred on the National Water Model, you know, they're optimizing around being able to predict what's possible in the next 30 days, the next quarter, the next season. You know, and when we're looking out at being able to support decision making for planning, you know, for decades and 50-year time horizons, then it lends to different decisions. And so we're being transparent and sharing those, and we believe that there's definitely a complementary nature to the work that they're doing and what we're doing, right? These physical models, we're trying to organize them in such a way that can be easily pulled into the flood inundation model, whether they want to use that just for calibrating their hand methods or for replacing those, being able to share and have more physical models for them to use is a value to them. And FEMA benefits because that's what we use when we're in a disaster, is the outputs from the National Water Model and that team. And so it's a complementary effort, and it's a good collaboration, I found.
All right, excellent. Thank you so much, David. I'm just going to I'll make one final comment, and then we'll move on with the agenda. The purpose of this task force is primarily to bring federal climate science into the process to update ASCE codes and standards and manuals of practice. ASCE is currently developing a manual of practice on compound flooding in the coastal zone. And so I'm going to encourage that committee to look at your presentation today. And if they have questions or want some input or whatever, is it okay with you if I just give them your email address and they can contact you directly, or is there a better process?
That would be great. Funny you say that, because the hour before this, before I joined, we were meeting with the Water Institute to see what the latest that they're doing in the compound flooding, what they've done for coastal Louisiana and Jacksonville. So they just briefed us on that in the hour before this. And so it's an area where we know the science is emerging, and we're trying to make sure that we preserve our statistics, both for our coastal and our inland watersheds, such that they can be leveraged for compound flooding. But it's no easy task. There's a lot of research going on in that space. So yeah, we'd be happy to talk to anyone who wants to about that.
Okay, I think the other big effort at ASCE is on nature-based solutions, engineering design guidance for nature-based solutions. That's probably a 2 or 3 year activity. But the kind of work you're doing here, I could see as being very relevant to that work as well. So I think there's some good synergies here.